Hello and welcome back to another Algebra 1 video. Today we'll be finishing up Chapter 3 with Lesson 3.5 on graphing linear inequalities in two variables. A linear inequality in two variables, which will be x and y, can be written as follows. Either ax plus by is less than, or you can also do less than or equal to c, and then we have ax plus by is greater than c, and you can also do greater than or equal to c. This applies where a, b, and c are all real numbers. A solution of a linear inequality in two variables is going to be an ordered pair, xy, that makes the inequality true. You might be wondering what making an inequality true means. Let's go ahead and look at this first problem to see what they mean. So we're going to tell whether the ordered pair is a solution of the inequality. We have the linear inequality 2x plus y is less than -3, and we're given an ordered pair -1, 9. We know that -1 is x, and that 9 is going to be y. So what we want to do is to substitute -1 for x in our inequality and 9 for y. So that would be 2 times -1 plus 9 is less than -3. Now all you want to do is simplify 2 times -1 plus 9. That would give you -2 plus 9, and that would give you 7. Then bring down your remaining terms. So your final inequality would be 7 is less than -3. Now you can evaluate whether the inequality is true or not. We know that 7 is not less than -3, so the ordered pair -1, 9 is not a solution. Here is another one of these problems where we're going to tell whether the ordered pair is a solution of the inequality. We have the inequality x minus 3y is greater than or equal to 8, and the ordered pair to -2. 2 is going to be our x coordinate, and -2 is going to be our y. So we know that we're going to plug positive 2 into x, and then -2 into our y. Once you've done that, you have 2 minus 3 times -2 is greater than or equal to 8. You can go ahead and simplify this by evaluating it. That would give you 2 minus 3 times -2, which is -6. These negatives will cancel out since you're subtracting a negative number from a positive number, and that would give you 2 plus 6 would be 8. So your final inequality would be 8 is greater than or equal to 8. Since 8 is equal to 8, we know that this inequality is true, and that 2, -2 is a solution. Go ahead and pause the video and try this problem on your own. Again, we're going to tell whether the ordered pair is a solution. We have the inequality 5x minus 2y is less than or equal to -1. We have the values -4, -1 for our ordered pairs. X is going to be -4, and -1 is going to be y. So I'm going to plug in -4 for my x and -1 for my y. Now if you plug this into the inequality, you would get 5 times -4 minus 2 times -1, and you can go ahead and evaluate that. I would recommend you keep the values inside the parentheses so that you don't have any mistakes in your positive and negative signs. So 5 times -4 is -20, and you would subtract that from 2 times -1, which is just -2. These negatives will cancel out, and you would get -20 plus +2, and that would give you -18. So your final inequality would be -18 is less than or equal to -1. Now you can evaluate this. Is -18 less than or equal to -1? It is, so the ordered pair is a solution. Here is one last problem for you to try on your own. We have the inequality negative 2x minus 3y is less than 15, and the ordered pair 5, negative 7. So in our ordered pair, 5 is going to be our x coordinate, and negative 7 will be our y. So I'm going to plug in 5 for x and negative 7 for y. Once you've plugged your values in, you have negative 2 times 5 minus 3 times negative 7 is less than 15. Once again, whenever you are working with negative numbers, I recommend that you put them in parentheses just to make sure that you are adding or subtracting correctly. So negative 2 times 5 would give you negative 10, and that would be minus 3 times negative 7, which is going to be negative 21. You're subtracting by a negative number, so your negatives will cancel and turn into an addition sign. And now you have negative 10 plus 21. And negative 10 plus 21 would just be positive 11, and your final inequality would be 11 is less than 15. Now that you have simplified your inequality, you can just evaluate whether it is true or not. We know that 11 is less than 15, so therefore our ordered pair is a solution. Now we'll be getting into graphing linear inequalities on a coordinate plane. Now the reason we graph linear inequalities in two variables on a coordinate plane is because we're able to visualize all the solutions of the inequality. So we have three main steps that we follow whenever we are graphing. You're going to first graph the boundary line for the inequality. And just like whenever you're graphing an inequality on a number line, you have special rules for whenever you're using less than or greater than, and when you're using less than or equal to, or greater than or equal to. In this case, when you're graphing your line, you're going to use a dashed line for less than or greater than, and then use a solid line for less than or equal to, or greater than or equal to. Secondly, you're going to test a point that is not on the boundary line to determine if it is a solution of the inequality. You're going to do that as we did in the previous four problems, where you plug in an x value and a y value to evaluate if the inequality is true. And I just wanted to bring your attention to this note on the bottom. It is convenient to use the origin 0, 0 as a test point because it can be easily substituted. However, you must choose a different test point if the origin is on the boundary line. And lastly, if the test point is a solution, you're going to shade the half plane that contains the point. And if it isn't a solution, then you will shade the half plane that does not contain the point. Let's look at our first example. We're going to graph y is less than or equal to 2 in a coordinate plane. Your very first step is to graph your boundary line. And the way you're going to do this is by graphing your related equation. What I mean by the related equation is just to replace your inequality symbol with an equal sign so that you're able to graph a linear equation. So rather than y is less than or equal to 2, you now have y equals to 2. And to graph this, you're going to use a solid line because the inequality symbol is less than or equal to 2. Recall from chapter 2 that any linear equation that is set to y and then a value represents a horizontal line. So this doesn't have an x value, which means it doesn't have a slope. So you can just plot a horizontal line here at 2 on the y-axis. So that's how your line will look like. And now you can move on to your second step, which is to test a point. Now, again, it's very convenient to test 0, 0 when it doesn't fall on the boundary line. As we can see on the graph, 0, 0 does not fall on y equals 2, so we're free to test it in our inequality. Now you would just plug in the y value 0 into your inequality, and that would give you 0 is less than or equal to positive 2. Now evaluate whether that is true. 0 is less than or equal to 2, so it is a solution. Now, because 0, 0 is a solution, you're going to shade the half plane that contains the point 0, 0. Now, what we mean when we shade the half plane that contains that point is just to shade the area where the point is on the coordinate plane. So in the case of this graph, our final result will look like this. You can see that we've shaded the entire plane where 0, 0 lies. So this is the half plane that contains all the solutions of the inequality. Here is another problem very similar to the last one. We're going to graph x is greater than 1 in a coordinate plane. Very first step is to graph your boundary line. First, make it into its related equation, which would just be x equals to 1. We're going to use a dashed line because the inequality symbol is greater than. Now recall from chapter 2, x set to any value, meaning it doesn't have a y variable in your linear equation, just represents a straight vertical line. So you're going to draw a vertical line here at 1 on the x-axis. That's how your dotted line will look like. And now you can test a point. Again, I'm going to use 0, 0 because it does not fall on x equals 1, and it's very convenient to test. So plug in 0 for your x value. That would give you 0 is greater than 1. 0 isn't greater than 1, so we know that 0, 0 is not a solution. Because 0, 0 is not a solution, you're going to shade the half plane that does not contain 0, 0. So that just means to shade the side of the line where 0, 0 is not on the coordinate plane. So that would be to the right of our line, and your graph would look like this. Notice how 0, 0 is not shaded in this case. Go ahead and try this problem on your own. We're going to graph y is greater than -1 in a coordinate plane. First step is to graph your boundary line. Your boundary line is going to be the related equation of your inequality, so that would just be y equals to -1. In this case, we're going to use a dashed line because the inequality symbol is greater than. So again, whenever you're graphing a line that is set to y and then just a value, that will be a horizontal line. So we're just going to draw a horizontal line on the y-axis at -1. So your line would look like this. Now that you've drawn your line, you can go ahead and test a point. I'm going to once again test 0, 0 because 0, 0 is not on our boundary line. So plug in 0 for your y value. That would give you y is greater than -1, 0 is greater than -1. We know that 0 is indeed greater than -1. So since 0, 0 is a solution, you're going to shade the half plane that contains 0, 0. So in this case, you're going to shade the area that is above our boundary line, or where 0, 0 is. And that's how your graph will look. Here's another problem for you to try. We're going to graph x is less than or equal to -4 in a coordinate plane. First step is to graph your boundary line. So we're going to graph our related equation, which is just x equals to -4. And we're going to use a solid line because the inequality symbol is less than or equal to. So whenever we have a linear equation that looks like x set to a value, we know that we're going to draw a vertical line on the x-axis at -4. So our vertical line will pass through -4 on the x-axis, and that's how your line will look like. Once you've graphed your line, you can go ahead and test a point. Again, I'm going to go ahead and test 0, 0 since it is convenient and it doesn't fall on the boundary line. We have x is less than or equal to -4. Plug in 0 for your x value, and you're given 0 is less than or equal to -4. This inequality is not true, so 0, 0 is not a solution. Because it isn't a solution, you're going to shade the half plane that does not contain 0, 0. In that case, it would be this area to the left of our line where 0, 0 is not located, and that's how your graph would look like. Now we'll be getting into a little bit more complex linear inequalities where we have a slope and a y-intercept. So for our very first problem, we're going to graph -x plus 2y is greater than 2 in a coordinate plane. Now we're going to be using the same exact 3 steps that we've been using in the previous problems, except now we have a few more additional steps when we're graphing. I'd recommend that you go back to my videos on chapter 2 if you need a little bit of a refresher in the different ways to graph linear equations. So first, you're going to graph your boundary line. I would just make this into the related equation by replacing the inequality symbol with an equal sign. Now, if you look closely, you'll see that the inequality is actually given in standard form, which is ax plus by equals c. Now, if you remember from chapter 2, you can actually use this form to find the y-intercept and the x-intercept and use those 2 points to graph on the coordinate plane, then connect it with a line. So I'll go ahead and show you how to do that. We have -x plus 2y equals to 2. Now, the way you want to do this is you want to plug in 0 for either x or y to find either your x or y coordinate. I'll do that first for our x coordinate so that we can find our y value. So 0 would cancel out, and now we have just 2y equals 2. Isolate y by dividing both sides by 2, and you get that y equals to 1. So your y-intercept on the graph is going to be 1. And you can do the same to find your x coordinate. So you have -x, and this time you'll plug in 0 for y, so that y will cancel out. And to isolate x, you would divide both sides by -1 to cancel out the negative, and that would give you x equals to -2. So now you can plot -2 on the x-axis, which is right there. And then you can connect those 2 points with a line if that's the method you wanted to do. However, you can also actually make this into slope-intercept form, which is the way I personally like to do it, since sometimes using standard form can get a little bit messy when the numbers are not perfectly divisible. So we would have -x plus 2y equals to 2. I'm going to first undo x by adding x to both sides since it is negative. And now you would have 2y equals to 2 plus x. Now remember that slope-intercept form is y equals to mx plus b. So to fully isolate y, divide both sides by 2. That would give you y equals to 2 over 2, which is just 1, plus x over 2. Now I just want to rearrange this to get y equals mx plus b. So that would be y equals to 1/2 x. Just imagine a 1 in front of this x, so that would be 1/2 x, and then plus positive 1, and there is your slope-intercept form equation. Now you can graph your line on the coordinate plane. Again, you can either use the intercepts method through standard form that I showed before, or you can use slope-intercept form. I prefer slope-intercept form, so I'll go ahead and first graph my y-intercept at positive 1, and then use my slope to plot other points. Slope is rise over run, and since our slope is positive, we're going to rise 1 unit and run 2, rise another 1 unit and run 2. 2 points are really sufficient, but you can go ahead and plot more if you want it to be more precise. And you can draw your line through your points. And now that you've connected your points, we can move on by testing a point. I'm going to test 0, 0 again, since in this case, 0, 0 does not fall on our boundary line. So plug in 0 for x and also plug in 0 for y. That would give you negative times 0 plus 2 times 0 is greater than 2. All of this just cancels out to be 0, and your final inequality is 0 is greater than 2. We know that 0 is not greater than 2, so our inequality is not true. And because 0, 0 is not a solution, you're going to shade the half plane that does not contain 0, 0. So in this case, the area that is above the line. And this is how your graph will look like. Let's look at this other problem. We're going to graph x plus y is less than or equal to -4 in a coordinate plane. First, you want to graph your boundary line, and that's by using the related equation. So just replace your inequality symbol with an equal sign. We're going to use a solid line because the inequality symbol is less than or equal to. Now, once again, you can either use the intercepts method with standard form, or you can convert it into slope-intercept form. I'll show you how to do both of those methods. So for intercepts, you would have x plus y equals to -4. You would plug in 0 for x to find your y coordinate. 0 would just cancel, and you would get that y equals to -4. Same goes for your x coordinate, except now you're going to plug in 0 for y. 0 will cancel out, and you get that x equals to -4. Now you can just go ahead and plot that on your graph. So -4 on the x-axis and -4 on the y-axis, and draw a line that connects those 2 points. You can also write this in slope-intercept form. So if you have x plus y equals to -4, and you wanted to write it in y equals mx plus b, you just have to isolate y by subtracting x from both sides. Now I just want to rearrange this so that it looks more like y equals mx plus b. So I'll just switch -x and -4. And there is your final slope-intercept form equation. Now you can graph your line. I'll go ahead and use slope-intercept form. So -4, and then for our y-intercept, and then use your -1 slope. So rise over run. In this case, we have -1 for our rise, so we'll go down rather than up, and then we'll run 1. So down 1 over 1, down 1 over 1. You can also do up 1 to the left and up 1 to the left. And now you can connect these points with a line. Also, I just wanted you to notice that if you keep going until you hit the x-axis, you'll get the exact same x-intercept of -4. Now I'll go ahead and plot my line. and that is how my line will look like. Now that we've drawn our line, we can go ahead and test a point to see what side we're going to shade. I'm going to use 0, 0 since it does not fall on the boundary line. So I'll plug in 0 for x and 0 for y. That would give you 0 plus 0 is less than or equal to -4. That would just simplify to 0 is less than or equal to -4. That isn't true, so we know that 0 is not a solution of the inequality. So because 0, 0 is not a solution, you're going to shade the half plane that does not contain 0, 0. So in this case, this area that is below the line right here. So if you were to do that, this is how your graph would look like. Here is a graphing problem for you to try on your own. We're going to graph x minus 2y is less than 0 in a coordinate plane. I'm going to first graph my boundary line, and I'm going to use a dashed line because the inequality symbol is less than. Now I'm only going to use slope-intercept form for this problem because if you were to use the intercepts method, you notice that you get the same value for both y and x, and that means that you would only have one point to graph. Recall that for linear equations, you need a minimum of 2 and able to make a line. So to make this into slope-intercept form, first write your related equation, which is x minus 2y equals 0. We're trying to isolate x or y and make this into y equals mx plus b. So I'm going to first subtract x from both sides. That gives me negative 2y equals to negative x. Now I can go ahead and divide both sides by negative 2 to isolate y. Think of a 1 in front of this x. So negative 1 divided by negative 2 would make this positive 1/2 x. And here is your final slope-intercept equation. Now that you've written your slope-intercept equation, you can go ahead and graph it. Whenever you don't see a value for b or your y-intercept, you assume that it is 0. So you would plot 0 for your y-intercept and then do rise over run. Our rise would be 1 and our run would be 2. So it would rise 1, run 2, rise 1, run 2. And I'm just going to go ahead and plot 3 points. Again, you just need 2 and then connect that with a dashed line. Now that you have your line graphed, you can go ahead and test a point. Now in this case, I'm not going to be using 0, 0 because it lies on our boundary line right here. So we have to use some other point that isn't on the boundary line. I'm going to go ahead and do 4, 4. Now I recommend that you use any positive value and the same value for both the x and y coordinate, so that if you do end up accidentally mixing up what you plug in for x and y, there won't be any error since both of them are the same. So I'll do 4, 4, and we can see here that 4, 4 is not on our boundary line, so it's all right to test. I'll plug in 4 minus 2 times 4 is less than 0. 4 minus 8 would just give you negative 4. Your final inequality would be negative 4 is less than 0. We know this is true, so negative 4 or 4, 4 is a solution. So we'll shade the half plane that contains the points 4, 4. So in this case, it would be this area above our line. And that is how your final graph will look like. That is it for today's lesson. Thank you so much for watching. As always, information regarding tutoring, lesson request, and additional practice will be linked down below in the description box. If you ever have any questions regarding our lessons, feel free to email me at kaylin.david24@gmail.com which you can also find in the description box. Feel free to share my content with fellow students who might be struggling with algebra. Thank you so much for your continuing support, and I hope to see you on the next video.